Question number 18. A shot put is spherical and has a mass of 7.26 kilograms. It is made of a metal with a density of 6.93 grams per centimeters cubed. Take pi to be 22/7. A. Determine the radius of the shot put correct to 1 decimal place. Now the first thing you're going to do is to check what you're given. We are given the mass of the shot put, which is given in kgs, and then the density is given in grams per centimeters cubed. So we need to know, given mass and density, how do we get the radius? So to get the radius, we need to get the volume of this spherical shot put. So to get the volume, volume is given by mass over the density. I need to be very careful, since you can see the mass is given in kilograms, so you need to convert these into grams, since the density is given in grams per centimeters cubed, so that you can have uniformity of these units. So multiply this by 1000, and this one will give 7260 grams. Now we can proceed and get the volume. Volume is equals to mass, which is 7260 grams, divided by density, which is 6.93 grams per centimeters cubed. So once you work out these, you will get the volume of this spherical shot put. So use a calculator to do this, and when you divide it, you get 1047.62. So approximately 4 significant figures. Of course, you're supposed to write this one to 1 decimal place. So correct 1 decimal place, it will be 1047.6. So this will be centimeters cubed. So that is what you're supposed to get as a volume. Now once you get the volume will assist you to get the radius. Since this one is a spherical shot put, how do you get the volume of a sphere? So volume of a sphere is given by this formula, 4/3 pi r cubed. So since you have the volume, you just need to equate. So 1047.6, which is the volume, is given by 4/3 times pi, which is 22/7, times the radius cubed. So making r the subject of this formula, you get r to be given by the cube root of 3 multiplied by 7 times 1047.6, everything divided by 4 times 22. So when you work out these, you get the radius. So use a calculator to do these. And this one, correct 1 decimal place. I'm trying to give all the answers, although you're supposed to give the radius correct 1 decimal place. But this will give 15.8 centimeters. So that is how you get the radius of that shot put, by first getting the volume, then using the volume to get the radius. Part B. A bucket is in the shape of a frustum of a cone. The base radius of the bucket is 7 centimeters. The bucket contains water to a height of 15 centimeters. The radius of the surface of the water is 10.5. Find the volume of the water in the bucket. It's nice to sketch. So this is a bucket made up of frustum of a cone. The base radius is 7. So let me draw that bucket. Just it like this, just a sketch of the bucket, and contains water to a height of 15 centimeters. The base radius is 7, and then it contains water. But then the radius of the surface of the water is 10.5. So this is the surface of the water, which is 10.5. So this is 10.5. Now, having that, we are supposed to find the volume of water in the bucket. Now, to do this, we shall complete let's complete this cone like this. This is how it was before it was cut, and we shall let this one to be height of this cone, so that we have two cones. So to get the volume of water in the bucket, you can see we have two cones. We shall get it by first getting the volume of the bigger cone, the cone that runs from 15 centimeters plus h, then subtract the smaller cone with a radius of 7. By doing so, we shall get the volume of the water. So the volume of the water will be given by the volume of the bigger cone, which has radius of 10.5, subtract the volume of the smaller cone with a radius of 7. But before that, we need to get this height, and to get this height we shall use similarity. So the height of the bigger cone, which is h plus 15, divided by the height of the smaller cone, which is h, is equals to radius of the bigger cone, which is 10.5, radius of the smaller cone, which is 7. So once you work out these will give 7h plus, so this is 7 times of 105 is equals to 10.5h. So when you work out the value of h, this question, you get I'm trying to shorten these workings. You get h is 30. So h will give you 30 centimeters. So therefore the height of the bigger cone will be 30 plus 15, which will be 45. Then the height of the smaller cone was 30. Now using these two, you can get the volume. So therefore the volume of the water will be given by, we get the volume of a big cone, which will be a third. Remember, the volume of a cone is given by a third pi r squared height. This is how we get the volume of a cone. So bigger cone a third times pi, which is 22/7, times radius. Radius of bigger cone is 10.5 squared. Then times the height, which is 45. So that is how we get the volume of the bigger cone, a third pi r squared height. Then you subtract volume of the smaller cone. Volume of the smaller cone would be a third times pi times the radius. This is 7 squared times the height, which is 30. So the volume of the bigger cone, a third times 22/7 times 10.5 squared times 45. That one will give calculator, this will give 5197.5. Then for the smaller cone, that times 22/7 times 7 square times 30, that will give 1540. This is centimeters cubed. So now, getting the volume of water, we get the volume of the bigger cone, 297.5, subtract the volume of the smaller cone. Now we remain with the volume of the frustum that contains water, and this gives 297.5 minus 1540 will give 3657.5 centimeters cubed. Write it down here. Get 3657.5 centimeters cubed. So that is how we get the volume of water in the bucket. Part 2. The shot put ball is completely submerged in the water in the bucket. Calculate the new height of the water in the bucket. Now, to solve that question, we're going to use the previous diagram. So we have the new height of the water there. So when we have the shot put ball submerged in the water, of course the water will rise to another level. So there is not something that we need to add here. We need to have an additional, so there's something, water will rise like this. So we shall have the new height. Let's say the new height will be there. Do a good sketch here. So I'm just doing a sketch of these. So this will be the new height, and I'll let this new height be represented by this new rise, be represented by x centimeters. So we need to get the new height of the water in the bucket, and that tells us that we need to calculate from 15 centimeters plus x. That will be the figure that is going to represent the new height of the water. 15 centimeters plus x. So we need to get this x, which is the rise. X is the rise. Now, to do this again, we shall be required to use similarity, and this time around you're going to consider one cone that runs all the way, the big cone, the whole of this cone, whose height is going to be 45, since you have 30 plus 15, so this will be 45 plus, so it will be 45 plus x. So that will be the height of the big cone. So using similarity, the height of the big cone, 45, so 45 plus x divided by the height of the smaller cone, which is 45. Look at the cone that we're using, the cone with the height of 45. So from 30, 15 up to this level. So that is a 45, that cone with the height of 45, from 30 to 15 is equals to the radius of the big cone. Now this is the new cone, we don't have this radius, so we let this radius be represented by r. So the radius of the big cone will be represented by r divided by the radius of the other cone, which has a radius of 10.5. So with this we have two unknowns, but what we are interested in is the expression for x, and x is the new height, the rise of the water. So I shall skip some workings here because I've done them already. So make x the subject of the formula. You just need to cross multiply, and when you do that, you'll get the expression for x as so x will be given by, we've already done this, 4.286r minus 45. So that is what you get when you cross multiply and you make x the subject. You get expression for x, which is the new height, to be that. So now, having this expression for x, we shall use this expression, and it will help us to get the new height of the water in the bucket. So how do we get these? Already we know the volume of the shot put. The volume of the shot put is known, and it is here, 1047.6. We can round off that one to, so let me write it here. So the volume of the shot put be given by 1047.6. For significant figures, you can round it off to 1048 centimeters cubed. So that rise is representing the volume of this spherical shot put. That rise, x centimeters, represents the rise in the volume, and that is the volume of the shot put. So what are you going to do? How do you get that rise? The volume, we are going to get the volume of the bigger cone with the height 45 plus x and the radius r, subtract the volume of the cone with the radius 10.5. We shall remain with the volume that is represented by that rise x, and that volume is actually the volume of the shot put ball. So we do that. So volume of the bigger cone will be a third times pi 22/7 times radius. Radius of the bigger cone is r, as you can see from the diagram here. So that will be r squared times the height. The height will be 45 plus x. That is what you're supposed to do. Then we subtract the volume of the smaller cone, which has a radius of 10.5. So that times 22/7 times radius is 10.5 squared, and the height, that volume, is 30 plus 15. That will be 45. By doing so, we shall get the volume of that part x, which is the volume of the shot put, because it is as a result of submerging the shot put. And this one will give 1048, the volume of the shot put. Now you can see here we have two unknowns. We have 45 plus x. The reason why we got this expression for x is so that we can substitute it here. So let us do the substitution. We have that times 22/7 times r squared, then times 45 plus x. But what is x? X is 4.286r. Put a different pen. 4.286r minus 45. So that is the height. And then minus that times 22/7 times 10.5 squared times 45 is equals to 1048. So again, I'll do simplify these. and you notice that these 45 and these get subtracted, and you will have that times 22 over 7 times r squared times 4.286 r. That is how simplify that. Then subtract. When you work out these, that times 22 over 7 times 10.5 squared times 45, you already got that. You will be 5197 is equals to 1048. Now having these now, it is very easy to work it out, and this will be that times 22 over 7 times here we shall have 4.286 r cubed is equals to, the other side this will be 6245. This is the point that I will need to simplify. Now making r cubed the subject, making r cubed the subject of the formula, you will get 6245. Sorry, you get 6245 times 3 times 7 everything divided by 22 times 4.286. So of course now to get the radius, you just need to get the cube root of these. The cube root of that will be 6245 times 21 divided by 22 times 4.286, and this will give, work out this, you will get 11.16. So radius is 11.16 centimeters. We don't got the answer. Since we are looking for that rise. So to get that height, remember this expression. Here we got that x is equals to, so x is equals to 4.286 r, so it is 4.286 r, and r is we got it as 11.16 minus 45. So therefore x will be given by 2.832. So the question is now asking about the new height. So we already have that x. So look at the diagram. We have the original height was 15. Then to get the new height, you have to add that x. So we'll take 15. So new height will be given by 15 plus 2.832, which will give 17.832 centimeters, and that is the solution, and that is how we're supposed to solve that question.